Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry, and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, and mathematics, then please do subscribe to my channel. So in my previous video, I was actually explaining the exercise questions which was there in exercise 7.1 in 9th standard triangles chapter. That is the 7th chapter in 9th standard mathematics. So now in the same exercise 7.1, the remaining questions we will look in this particular video. Now here we will start from fifth question. So 1 to 4 I have already explained in my previous video. Please refer that video for 1 to 4 questions. Now in this video we will start from fifth question. So in fifth question also here you have one diagram. So let us draw that particular diagram. So you have two rays like this. So this particular point is A, and there is one particular line segment which is exactly bisecting this particular angle A. So whenever I use the word bisection, that means it bisects the two things into two equal halves. Now this particular line is named as L. This point is A, and there is a perpendicular line drawn to this particular ray. So this particular ray, there is a perpendicular line drawn. So here we have a perpendicular line drawn to this particular ray. So this angle is 90 degree. Similarly, there is one more perpendicular line drawn to this down ray. Here also you have the angle 90 degree. This point is B, this point is P, and this point is Q. So based on this diagram, you have to solve the questions which are there in this particular fifth question. So here they have clearly said that L is bisecting the angle A. So that means this angle will be equal to this particular angle. That is, they have given here. Now B is any point on L. So this particular point B is any point on L in such a way that from B to the first ray they have drawn one perpendicular line, and from B to the second ray they have drawn one more perpendicular line. So this angle will be 90 degree and this angle will be 90 degree. So now BQ is perpendicular. This particular BQ is perpendicular and BP is also perpendicular to the down ray. So based on this, you have to prove, in the first question, you have to prove triangle APB is congruent to triangle AQB. Basically, these two triangles. Here, now we'll look into the solution for this first question. Here in triangle, so in triangle APB and triangle AQB, you can see AB acts as common side. So, or else first we'll consider the angles. So here BQA is equal to BPA, which is equal to 90 degree. This is, they have already given. So they have already given. Now QAB is equal to BAP, because here line L is bisecting. So here line L is bisecting angle A. Now AB is equal to AB because AB acts as the common side. So here AB is common side. So this is bracket. So AB is common side for both the triangles. So AB is equal to AB. So now we are getting two angles equal on one side. So angle side we are getting. So therefore, according to angle side theorem, so according to angle side theorem, triangle here, which triangle we are considering? We are considering triangle APB and AQB. So triangle APB is congruent with triangle AQB. Now we will look into the second question in the same fifth question. Here you have to prove BP is equal to BQ. So that is, this particular BP is equal to this particular BQ. You have to prove. Since here we have already proved these two triangles are congruent with each other. So since triangle APB is congruent with triangle AQB, therefore straight away you can write BP is equal to BQ. So this is the solution for fifth question. So now we will look into the sixth question. Here they have given little bit complicated diagram. So I'll just try to write this diagram roughly. So you have one triangle like this. So this is A, D, B, and there is one line from D to E, and this AE is also connected. So this point is E, and there is one line coming from E towards C like this. So this point is C and this is connected to C, and there is one more line coming from A to C like this. So now here you have this particular diagram. So I'll just try to make it more straight. So this, and here you have this point. So AB, so here BC is a straight line. So A, B, D, C, E. So this is one diagram which they have given. Here this particular line AC is equal to this particular line AE, and this particular line AD is equal to this particular line AB. Based on this, and they have also given this particular angle BAD, not this center part, only BAD, this particular angle, and EAC, this particular angle. So the center point you should not consider, the center angle you have to not consider, this angle you have to consider, that is EAC, this angle you have to consider, that is BAD. So these two are equal. So what and all things they have given here? They have given AC is equal to AE, and they have given AB is equal to AD, and they have given BAD is equal to EAC. So these are the three data which they have given in this particular question. So based on this, you have to prove. So here we have to prove that BC is equal to DE. So that is this particular total line what is there here. So BC is equal to this particular line D. So here we will consider two triangles in this. So I'll write those two triangles separately which I am considering here. I am considering this triangle ABC. So I am considering one triangle ABC. That is, I am ignoring this AD line and I am considering this ABC triangle. So this particular ABC triangle I am considering, and I am considering ADE triangle, that is this particular triangle. So ADE. So this particular triangle I am considering. So ADE. These two triangles I am considering, and I will prove these two triangles are congruent with each other. So here in the data they have already given AB is equal to AD, and they have also given here AB is equal to AD. So AB is equal to AD, and also they have given AC is equal to AE. So that is this particular side is equal to this particular side. So these two triangles I will just write in the new slide. So we have two triangles like this, A, B, C. So here this is A, this is B, and this is C. There is one more triangle like this. So there is one more triangle which is A, D, and this particular triangle like this. So A, this is E, and this particular point is D. So AD, AB is equal to AD, and here AC is equal to AE. Now we have to prove one angle in between these two sides, that is this angle and this angle are equal to each other. We have to prove this. So in order to prove that, first we will write AB is equal to AD because this is already given. So now here we have to consider triangle ABC and triangle AD. So these two triangles I am considering, in which AB is equal to AD, which they have already given. So in this diagram you can see here there is one angle in the center. So if you want to get the total angle AD, so that is this particular total angle AD, if you want to get, sorry, DAE, if you want to get this angle and this angle, you have to add. And similarly in this triangle, if you want to get this total angle BAC, then you have to add this angle and this angle. So that center angle acts as the common angle for both the triangle. So now here consider BAC angle. So consider BAC angle, which is equal to BAD. So here BAC angle is equal to BAD plus DAC, because here you can see this is BAD and this is DAC. So if you add those two angles, you'll get total BAC angle. So similarly consider DAE angle. So in DAE angle, here DAC plus, so that is this particular angle DAC plus CAE. So this particular angle CAE. So DAC plus CAE. So that means here we are getting BAC is equal to BAD plus DAC. And here we are also getting DAC plus CAE for DAE. So here DAE is equal to DAC plus here what we have CAE. So CAE. In both of this, DAC is common. So in both of this, DAC is common, and the data which they have given here is BAD is equal to CAE. So here they have given BAD is equal to CAE. So if you consider this as equation 1 and if you consider this as equation 2, in the question you have BAD is equal to EAC. Since BAD is equal to EAC, let's call this as equation 3. So substitute 3 in equation 1. So if you substitute 3 in equation 1, then BAC will be equal to, in the place of BAD, I can write EAC. So in this BAD place, I am writing this EAC plus DAC. So what is there in equation 2? What is there in equation 2? In equation 2, we have DAE is equal to DAC plus CAE. So CAE means it is nothing but EAC. So here you can see RHS are becoming equal in this both equation. So here since RHS are equal, angle BAC will be equal to angle DAE. That is, these two angles are equal to each other. So that means here we are getting AB is equal to AD. This is actually given. We have proved this. Now here in this diagram they have already given AC is equal to AE. So AC is equal to AE. This is also given. Now according to SAS axiom, so therefore according to SAS axiom, here triangle ABC is congruent with triangle, therefore BC is equal to D. Since these two triangles are congruent with each other, straight away you can write BC is equal to D. So that is this particular side will become equal to this particular side. So there is lot of possibility that you can go wrong in this particular question. So always you have to name the points properly, and then you have to derive the triangles and write them separately. Then compare both the triangles congruency, see whether those two triangles are congruent, and then prove that whatever they have asked to prove. So writing the diagram is very important, naming the points is very important, and while writing the angles, sides, all those things, you should take care about the names, that is A, B, C, D, E, F, whatever names you give for the points, those things you have to carefully consider, or else you might go wrong in these kind of questions. Now we will look into seventh question. So in seventh question we have one diagram. So there is one straight line like this, and there is one line like this, and there is one more line like this. So this is little bit far away, and here we have one more line for this particular point, and this is connected to this point. Here this point is P, this point is A, B, this is D, and this is E. Here this particular angle is equal to this particular angle, this particular angle is equal to this particular angle. So now AB is a line segment and P is the midpoint. So that means they are saying P is the midpoint of AB. So this side will be equal to this side. And here D and E are points on the same side of AB. So that means on the same side this D and E are lying. So on the upper side of AB, this D and E are lying. Such that here BA, here they have given BAD. So this particular angle BAD is equal to ABE. So that is this particular angle. And EPA. So this particular EPA angle is equal to DPB. So that is this particular angle. So based on this data, you have to prove triangle DAP is congruent with triangle EBP. So that means basically we have to prove these two triangles are congruent. I am just writing these two triangles separately like this. So we are writing these two triangles separately like this. So this is PB, this is E, this is D, this is P, this is A. So here, since P is midpoint, or before considering side, we will consider two angles which they have already given. So here consider, so here we are considering ADP triangle, and here we are solving the first question. So ADP triangle and triangle EPB. So in these two triangles, here they have already given DAP is equal to EBP. So DAP is equal to EBP, which is already given. So this thing is already given. So one angle we have proved that they are equal to each other. Now in order to prove the second angle equal, so we have to consider this center angle also, which is there over here. So this center angle is the common angle for both the triangles. So if, because this both the triangles are merged like this in this diagram, so this center angle is same for, we have to consider that for the total angle. So now in triangle A, so here in triangle, so in triangle APD, so in this particular triangle APD, here this particular total angle APD, so this particular total angle APD, you have to consider this angle and this angle. So sum of these two angles will give you the total angle APD in triangle APD. So if you want to consider the angle APD, that is equal to here this particular side, that is EPA. So here EPA plus here EPD. So this particular angle. So EPD. So EPA plus EPD will give you angle APD. Call this as equation 1. Similarly, in triangle EPB, so in triangle EPB, here this particular angle and this particular angle, if you add, so then you will get the total angle EPB. So DPB plus EPD. So here EPB, here EPB angle is equal to here DPB. So DPB plus EPD. This you can call as equation 2. And we know that EPA and DPB are equal to each other. So in the place of DPB, I'll write EPA only. Because since EPA is equal to DPB, since EPA is equal to DPB, therefore equation 2 I can write as EPB is equal to EPA. So in the place of DPB, I am writing this EPA because EPA is equal to DPB. So EPA plus EPD. So this you can consider equation 3. So here in equation 1, we have APD is equal to EPA plus EPD. So in equation 1, we have APD is equal to EPA plus EPD. And in equation 3, we are getting here in equation 3 we are getting EPB is equal to EPA. So EPB is equal to EPA plus EPD. So here you can see RHS are becoming equal in both the equation. So therefore APD is equal to EPB. So that means in these two triangles, we have proved that DAP is equal to EBP. This is already given in the question. And now, just now we have proved these two angles are also equal. So that is APD is equal to EPB. This we have proved. Now, here in this diagram, you can see P is the midpoint. So since P is the midpoint, since P is midpoint of A and B, so P is midpoint for A and B, therefore AP will be equal to PB. So that means here we are getting angle side. So we are getting angle side. Therefore, according to angle side theorem, so according to angle side theorem, here triangle DAP is congruent with triangle EBP. So this is first question. So in the same seventh question, if you come to the second question, here you have to prove AD is equal to B. So that means here this particular side you have to prove that is equal to this particular EB side. So since triangle DAP is congruent with triangle EBP, therefore AD will be equal to B. So second question also we have proved. So now we will look into the eighth question in this particular exercise. Here in eighth question you have one diagram like this. So one M is written here in this particular diagram. So these points are named as D, B, C. This is A and this point is M. Now in the right angle triangle, so they are already given right angle triangle ABC. So that means here they have given right angle triangle ABC means this particular angle will be 90 degree. And they have given right angled at C. So that means this particular angle is 90 degree. So ACB is 90 degree. M is the midpoint of hypotenuse AB. So that means this M acts as the midpoint of hypotenuse AB. So this MA and MB will be equal to each other. Now C is joined to M. So that means this here MC line is joined like this, and here produced to a point D. So now this line is produced to point D, and DM should be equal to CM. So that means these two lines should be equal. So that is CM should be equal to DM. Now point D is joined to point B. So that means this particular line we have drawn here. So based on this data, what we are understanding is here AM is equal to BM, and here DM is also equal to CM. So these two data we are getting based on this statement. So now you have to prove in the first question that triangle AMC is congruent with triangle BMD. So now we have to consider. So in order to prove this particular first question, we will consider triangle AMC and triangle BMD. So that is this particular AMC. So this triangle and BMD, that is this particular triangle, you have to prove they are congruent with each other. So here clearly you can see that this particular side DM is equal to CM, and here DMB, so here DMB will be equal to, so that is this particular angle will be equal to AMC. So here DMB is equal to AMC. This is because they are vertically opposite angles, because here AB and CD are straight lines. So DMB and AMC are vertically opposite angles. They will be equal to each other. So they are vertically opposite angles. So DM and CM are equal because this is already given in the question. Similarly here AM is also equal to BM. So AM is also equal to BM. So this is also given. So that means here according to SAS axiom. So here therefore according to SAS axiom, here triangle, this particular AMC is congruent with triangle BMD. So now we have proved these two triangles are congruent. Now looking into the second question, in the 8th question, you have to prove that angle DBC is equal to 90 degree. So that is this particular angle DBC is equal to 90 degree. You have to prove. So now in order to prove DBC angle is equal to 90 degree, since a triangle AMC is congruent with triangle BMD, so since triangle AMC is congruent with triangle BMD, here these two angles will be equal. So that is this particular angle and this particular angle will be equal. So that is DBM and MAC. So DBA, so here DBM is equal to MAC. So that means these two angles. So MAC is equal to DBM. So DBM is equal to MAC. So these two are equal because triangle AMC is congruent with triangle BMD. Since DBM and MAC are getting equal to each other and they are alternating angles, so here alternating angles are getting equal to each other. So therefore DB is parallel to, so DB is parallel to AC. So now we have proved that DB is parallel to AC. Now here DB is parallel to AC. So since DB is parallel to AC, here BC acts as the traversing line. So here BC is a traverse line and here BC is the traverse line, and the angles on the same side of traverse line, if you are adding, together, then it will be equal to 180 degree if you remember the sixth chapter. So if you don't remember, then you can go back to my previous videos on sixth chapter, that is on lines and angles. There you can get the clarification. So here we have this particular BD or this particular DB is parallel to AC. So here DB is parallel to AC. So this BC acts as the traverse line. So these two angles will be the corresponding angles on the same side of the traversing line. So if you take sum of those two angles, then that will be equal to 180 degree. So since BC is a traverse line and DB is parallel to AC, here DB, so this DBC plus ACB will be equal to 180 degree. So here ACB we already know that is equal to 90 degree. So DBC plus 90 degree is equal to 180 degree. 90 degree you can bring to RHS. So DBC will be equal to 180 degree minus 90 degree. So DBC is equal to 90 degree. So this is the second question. In the same question you have the third question. So here you have to prove triangle DBC is congruent to triangle ACB. So now in order to prove this particular third question, DBC is congruent with triangle ACB, here we can straight away consider the second question. We have solved that DBC is equal to 90 degree. Here ACB is also equal to 90 degree. So DBC is equal to ACB is equal to 90 degree, which we have already proved. So one angle is getting equal to each other. So here basically we are taking these two triangles. So one is this triangle, the other is this particular triangle. So that is, this is DBC and we are considering ABC. So this is equal to 90 degree, this is equal to 90 degree. Since we have already proved that triangle DMB, so we already proved that DMB is congruent with triangle AMC, and here BC is equal to BC because they act as common side. So that is, this particular side act as common side for both the triangle. So BC is equal to BC. Triangle DBC is congruent with triangle ACB. So in fourth question you have to prove CM is equal to half AB. So you have to prove CM is equal to half AB. So here we have already proved. So here we have already proved this particular triangle DBC is congruent with triangle ACB. So that means here this particular AB will be equal to CD. So here AB will be equal to CD. So here CD is nothing but CM plus DM because M is in between C and D. Now we have also proved this, you can call as some equation, you can call this as equation 1. Nowhere we have given equation in this question, so you can consider this as equation 1. And we have also proved this these two triangles, that is triangle AMC is congruent with the triangle BMD. Since these two triangles are congruent with each other, here CM was equal to DM. So this you can call as equation 2. So now in equation 1 we have AB is equal to CM plus DM, and from equation 2 we have CM is equal to DM. So now you can substitute DM with CM here in this particular. So in this particular CM place you can substitute this DM because CM is equal to DM. So therefore equation 1 becomes AB is equal to DM plus DM, because in the place of CM I am substituting DM. So since I am substituting DM here, AB will be equal to 2 times DM, or here since this particular CM is equal to DM, I can write this as AB is equal to 2CM also, because Cm is equal to dm. So since Cm is equal to dm, I can write AB is equal to 2Cm. So this 2 you can bring to LHS. So that becomes 1 by 2 AB is equal to Cm, or you can write this as Cm is equal to 1 by 2 AB. So we have proved all the 4 questions in 8 question. This is all there in this particular video. Like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.